Assalamu alaikum, myself Sheikh Zubedia. So today's our topic is conduction of heat. So let us get into the video. Introduction to heat conduction. Heat conduction is a process by which heat energy is transferred from matter. It occurs due to temperature difference within a material or between materials in contact. So this phenomenon is essential in various applications from cooking to thermal insulation. The basic of heat transfer. Heat transfer can occur through the three primary mechanisms: conduction, convection, and radiation. Conduction is the transfer of heat through direct contact between materials. Understanding this mechanism is crucial for effective thermal management in engineering and sciences. So this is a small mechanism of heat transfer. This picture indicates how the transfer and everything is done. The mechanism of conduction. In conduction, heat transferred through the vibration and movements of particles. When higher energy particles collide with lower energy particles, energy is transferred, rising the temperature of cooler areas. So this microscopic interaction is responsible for the overall heat flow in fluid solids. Facts affecting conduction. Several factors influence the rate of conduction, including uh, material properties, temperature difference, and surface area. Good conductors like metals allow heat to flow easily, while insulators like um, rubber resist heat flow. The greater temperature difference, the faster the rate of heat conduction. So Feuer's law of conduction. Feuer's law states that the heat transfer rate through a material is proportional to a negative gradient of temperature. Mathematically, it is represented as Q is equals to minus K. So the law says that heat transfer states that the rate of conduction Q is the variable through a plane layer is proportional to the temperature difference across the layer and the heat transfer area. A perpendicular direction of Q but is inversely proportional to the thickness of the layer. So dx dot dx in symbol Q infinity minus Q into A dt by dx. Find an equation of thermal conductivity. Thermal conductivity is a material property that qualifies its ability to conduct heat. It varies widely among different materials, with metals typically having high thermal conductivity and insulating materials having low values. Knowing the thermal conductivity of a material is vital for thermal design in engineering applications. So there are some fine ceramic materials like carbon, silicon nitride, alumina, silicon carbonate, aluminum nitride. So this is the thermal conductivity of the properties. Next, applications of heat conduction. Heat conduction plays a crucial role in everyday applications, such as cooking, heating system, and electronic devices. For instance, cookware is designed to maximize conduction for even cooking. Understanding conduction helps engineers design better thermal management system in electronics to prevent overheating. Insulating and heat conduction. Insulation materials are designed to minimize heat conduction and are used in buildings and appliances. Effective insulation reduces energy cost by maintaining temperature and reducing heat heat loss. Common insulation materials include fiberglass, foam, and reflective barriers. So, real world example of conduction. A practical example of conduction is a metal spoon heating hot when getting hot when placed in a pot or boiled water. Similarly, heat travels from the warm side of a wall to the cooler side even during winters. These examples illustrate how conduction affects our daily lives and the importance of material selection. Conclusion and future perspective. Understanding heat conduction is essential for advancement in technology and energy efficiency. Ongoing research focuses on new materials that can enhance conduction properties, improving thermal management. As we strive for sustainable solutions, optimizing heat conduction will play a pivotal role in future innovations.